find the x2 component of the vector curl, that's curl of V. That's the same as rotational of V is the same of nabla cross V. Now, let's use the permutation, the notation. See, look, curl of V is epsilon I j k. Don't forget here, you see partial V respect to x. This k comes over here, and this is j over there. Now, you want the x2 component, so let's do I is equal to. Now, let's develop it here. So, this will be epsilon 2 jk partial of vk with respect to xj. This is equal, this is equal. Now, you see, let's develop first on j. So, j can be epsilon, let's put here, epsilon 2 1k partial of vk with respect to x2, now plus epsilon. Now you see j here, if j is 1, okay, now let's put here 1, okay. Now look, if j, now I'm summing on j, so j is 2, but for j is equal to epsilon 2 for any k will be 0. So in this case it will be epsilon 2 3k, you see, 2 3k partial of vk with respect to x3. Now, for sure, k here cannot be 1 because epsilon 2 1 1 is 0. K here cannot be 2 because epsilon 2 1 2 is 0. So for sure k here must be 3. Okay, in this term, k only could be 1, can be 1. You see, so this is 3, I put 3 over here, and this is 1, I put 1 over here. Now, because 2 3 1 is different from 0, now let's do here, this is 1, 2, and 3. See, this is 1, 2, and 3. Now, 1, 2, 3, and 3, 1. This is plus 1. Now, let's see. 2, 1, 3. You see, look. 2, 1, 3. So, the order is reversed. So, this is minus 1. Now, 2, 3, 1. You see, 2, 3, 1. So, this is plus 1. So let's write down here first this one. It will be partial of v1 respect to x3 minus partial, let's put minus over here. So minus partial of v3 respect to x1. So this is the x2 component. Now, suppose you want the x1 component. You see, this is, don't forget this. You have here 1, 2, 3, 1, 2, and so on. Now, before 1 is 3, so I can write here partial v3. Before 3 is 2, partial x2 minus, now this is 3, before 3 is 2, and before 1 is 3. It's 3. So this here is x1 component. As we did in the last video, suppose from here you want x3 component. I'll just write here. You see, after 1 is 2. So partial of v2, x3, this is x1 minus. Now, after 3 is 1, v1 respect to after 1 is 2, respect to x2. So this here is x3 component. See, it's very, very easy now. You see, you can check. See, that's the first one. Do you remember? This is x2 component. This is x2 component. Do you remember? Now, you just cross over here, you see, and this starts first in this direction. Partial v1 respect to x3, it's here. Now, minus partial of v3 respect to x1 is right here. For instance, the E3 component, you see? Now, partial of v2 respect to x1. You see? Partial of v2 respect to x1. Now, minus, you see, minus partial v1 respect to x2. So this is x3 component. The x1 component, you just cross here. So partial v3 respect to x2 is here, minus partial v2 respect to x3. We got check. So using this epsilon ijk, don't forget this partial of vk respect to xj. This k goes there and j goes here. Find the Cartesian notation of divergence of curl of A. Divergence or rotational of A. Now, first of all, this here, this term here is a scalar. A scalar. You see, divergence of a vector is a scalar. So I'm sure there is no free index. You see, when I develop here, I already know that cannot appear a free index. Now let's develop this. Let's see. Let's call the curl of A is equal the rotation of A, let's call vector U. So what I want is divergence of U. That's a vector. Now let's represent the curl of A in terms of the permutation symbol. So this ijk, now partial of A, partial of X. The K goes up there and J comes up here. So this is my vector UI. Now divergence of vector U. So this will be the divergence of U is equal UI, comma I. Because what is this? This is a scalar, divergence of U, partial of UI respect to xi. I just wrote this. So the divergence of U, I can write like I put the comma over here. So this will be epsilon ijk. Now partial of AK xj partial of xi. So this will be a second derivative. I can write here this because look, fijk is a constant. So the derivative respect to xi, this is a constant. So this is epsilon ijk. Now ak comma ji. See, back here, that's the divergence of a curl of A. You see clearly that I is dummy, J is dummy, and K is dummy. So this is a scalar. This is scalar. Let's develop the curl of A. Now, this is a vector quantity because a curl of a vector is a vector. So this is a vector, which means that one free index. You see, when I use a notation, a Cartesian notation, the Einstein notation, in the final, we must have one free index. So again, let's call this U. So the vector U is Ui, is epsilon ijk. Now, this is partial of AK with respect to xj, as we did before. Now, let's develop the rotational of U. Now, rotational of U, you see, this will be, now, I always recommend you to use different letters when you write here, you see. Now, the rotational of U, let's put epsilon PQR. Now, partial of U, partial of X. Do you remember? R comes here and K comes there. Now this is, now you see, look, I want to substitute U over here. Now this is UI, so I substitute this letter R by I here, by I here. You see? And epsilon PQI is the same, you see? I jump, I move once and twice. This is equal epsilon I PQ partial of UI with respect to XQ. No problem. You see, now I substitute this UI right here. See, this is UI and this is UI. Now you see, I called the curl of A, I call vector V, so that's why I put V over here. Now I substitute UI, you see UI right here, you see. Now epsilon ijk, epsilon IPQ, partial respect to XQ of partial of AK with respect to XJ. I just wrote that. You see? Look, this is the UI. See, UI. Look, epsilon IJK. See? Now partial of AK with respect to XJ. See? That's a UI I just plugged over there. Now let's use that property. As I said before in other videos, other lectures, you just put delta delta minus delta, delta. Now here, AK, XK, XJ. See, now, this is I, this is I. So, JP, JP. Now, KQ, KQ. Now, JQ. You see, that's the second one, the third one. Now, JQ. Now, the third one with the second one. KP, KP. Now let's apply the property of delta. So I will do like this. Let's raise here. And this will be equal. Now, you see, delta JP. So this will apply over here. So instead of J, I write P. So this will be second derivative of AK. Now partial of XQ, partial of JXP. See, JP, you see, remove J and put P. Now, I applied this here, now this here. Now, you see, delta KQ. I just put, let's put K over here. K over here. You see, because KQ, remove K and put Q. Now it will be the minus sign. See this minus here. Okay. Now, delta JK. Again, I remove J and put K here. Now it will be partial of A, K, and put K over here. See, look, delta JK, okay, I remove here, I remove K and put delta JK and put J, or put K, okay, look, delta KQ, see, I remove K and put Q, and then delta XQ, delta XJ. Now, again, delta KP, I remove K and put P, see, or here, see, this is KP, or I put P here, or I'm sorry, or I put P here on this K, then that will be P over here, see? Now, this one again, this one, delta JK, you see, I remove J and put Q, okay? Verify the identity. Divergence of A cross B identical to the dot product of B curl of A minus A dot curl of B. Before we will develop this, now you see that each term is a scalar quantity. You see, divergence of a vector is a scalar. This is dot product, a vector and a vector, dot product, a vector and a vector. So this is a scalar. So when you use tensor notation, Cartesian tensor notation, and the final cannot appear any free index. Okay? In advanced, I can analyze and see this for sure. Now, as we did before, let's call vector u. So ui is equal epsilon ijk. Now a cross b AJ BK. Now, divergence of U, so the divergence of U will be the partial derivative of UI with respect to xi. So I will plug UI over here, so and epsilon ijk is constant. This is a partial derivative, so epsilon ijk is constant. Now, partial with respect to xi, AJ BK. Now, as I said before, you see, there is no free index here. I is dummy, J is dummy, and K is dummy. So this is scalar, as I was expected. Now, let's develop this derivative over here. So this is equal epsilon ijk, epsilon ijk, you see, BK, partial derivative of AI with respect to xi, you see, plus epsilon ijk, now of AJ, partial derivative with respect to xi of BK, you see. Now this is a partial derivative of a product, okay. This will be BK partial of AI with partial A, I'm sorry, this is AJ, okay, this is AJ, okay. Now BK partial of AJ with respect to xi plus BK partial derivative of AJ with respect to I plus, in this case, AJ partial derivative of BK with respect to xi. See, that's a derivative of a product. Attention here. Look. Partial of W. Now, this will be epsilon. Let's put PQR. Now, partial. This is X, this is W. Remember, you see, look, this R here comes here, and Q comes here. Don't forget that. You see, I'm just giving this as to, because we're going to use right here. So, look, this is equal to BK. Now epsilon ijk, you see, epsilon ijk, partial of. Now you see, K here can move once and twice, so this is equal Kij. You see, this is equal Kij because I moved twice. You see, once change the sign, and twice change the sign again. So Fijk is epsilon Kij. Now this will be AJ and Xi. Now please look here and look here. You see, this J over here goes here. You see, this R goes there, and I goes there. So this is equal a vector that I can write like rotational or curl of A. You see? And here the free index is K. You see? But BK over here, BK and K over here, so this is equal, let's put here B dot curl of A. No, you see, this is equal B curl of A, this term or the whole thing here. See how easy? You see, just look at here, R goes there and Q goes there. So J goes there and I goes there. And epsilon ijk is the same as epsilon kij. So I got this. Now let's work on this part over here. See this here. Okay? I just copied from here to here. You see? I just copied from here to here. See? Here I put over here. Now, you see, here I can write like this. I put AJ. Now, this is epsilon ijk partial of bk respect to xi. Now, here's a trick, okay? I'll just move j once. See? Look, this will be equal minus ij epsilon j ik partial of bk with respect to xi. You see, I just move j just once from here. You see, from here. Let's put here j I k. You see, j was here. The second here is come. Okay, this come j over here. Okay, this continuous ij. Now look here and look here. You see, R goes there, so K goes there. I, the second place, Q goes there, and I goes there. So this is correspond to, you see, rotational of B. You see? Now, what is the free index here? Is the blue one. Now, for this whole term, J now is dummy. So A, this will be A dot the curl of B, which is okay over there. See? Now you have to pay attention and write down this here. Okay, the rotational or curl of W, you see, and use these in this whole development.